So here's another problem. Here we're going to tackle it. So we have 4 times 3 to the power 2x plus 2 minus 3 to the power x minus 1 times 3 to the power x plus 1. In the numerator, once again, we have how many terms? One term, and then we have a second term. The second term obviously has two bases, two numerical bases, 3 and 3, but the multiplication, we know that what does it do to terms? It combines them. So that's why we have one term, and then we say this is our second term, separated by a minus sign. At the bottom, we have one term as usual, 9 times 3 to the power 2x plus 2. But now here's something that we need to note very quickly. Our base here, that is a numerical prime base, is 3, but it's raised to the power 2x. So when we do split, we're going to have a 3 to the power 2x for our unknown variable. On the right side, we can see there's 3 to the power x, and there's 3 to the power x. That does not give us the same thing as 3 to the power 2x, which means there's some work that needs to be done here. But we remember something, that laws of exponents do say that when bases are the same and we are multiplying, what do we do to the exponents? We add them. So we are going to take a bit of a guide from that. So before we split, let us apply the law of exponents for these two bases that have the same base. All right, 3 to the power x. Now, if we add the exponents, we're going to say x plus x, which gives us 2x, then minus 1 plus 1, which gives me 0. So in the numerator, that is basically my second term. It's 3 to the power 2x. 9 times 3 to the power 2x plus 2. Now we can go ahead and split the numerator terms. 3 to the power 2x split 3 to the power 2. Minus 3 to the power 2x over 9 times 3 to the power 2x split 3 to the power 2. Continuing on, in the numerator, you can clearly see that there's a common factor, 3 to the power 2x. So let us take that out, which leaves us in the left with 4 times 3 to the power 2. On the right, we are left with, what's 3 to the power 2x times what gives me back 3 to the power 2x? I'm left with 1. Very important, okay? Over 9 times 3 to the power 2x times 3 to the power 2. Now, multiplication, so therefore cancellation is possible. 3 to the power 2x and 3 to the power 2x will leave me with 1 and 1. All right, so then in the numerator, I'm left with 4 times 3 to the power 2. 4 times 9 minus 1 over this 3 to the power 2x cancels, or there's no x there, sorry, there was no x, okay? So there shouldn't be any x there, so let's just omit that. It's just 3 to the power 2. Then we are left with 9 times 3 to the power 2, 9 times another 9, all right? Unless, of course, we actually wrote down the question incorrectly, and this was supposed to be minus, okay? In that case, then obviously, but let's just stick with what we have. We said it's plus 2, so let's continue with that vein, okay? All right, so in the numerator, BODMAS needs to apply. We have 4 times 9 minus 1. Obviously, the priority needs to be on the multiplication before the subtraction. So 4 times 9 is 36 minus 1 over 9 times 9 is 81. Final answer, 35 over 81. Okay, so that is basically how we would go about simplifying this exponential expression. Bit different from the one problem down in part 2, all right, because what we had seen here is that this 3 to the power 2x, there was no way we are going to take out a 3 to the power 2x on this side unless we actually applied law number 1 of exponents for these two bases on the left side, on the right side, okay, of our two terms. So yeah, hopefully that was